llegan al control de las máquinas y herramientas. Esta conferencia va a estar impartida por Dave Morley, gerente de ventas de América de Digitalización de Máquinas y Herramienta, y Vivek Furtado, responsable de Digitalización de Máquinas y Herramientas en Siemens Industry Software. Voy a cederle el micrófono al ingeniero Benjamín López de Siemens.
¿Qué tal? Mi nombre es Germán Esparza, por ahí nos confundimos en las tarjetas. Yo estoy localmente en la oficina, pero Vivek y Dave nos apoyan a nivel Américas con los proyectos de digitalización de CNCs. Entonces, yo voy a estar aquí para contestar preguntas. La presentación es en inglés. Asumimos que ustedes entienden, pero si no entienden, por favor, levanten la mano. Yo voy a estar apoyando, igual en la sesión de preguntas y respuestas. Yo voy a estar apoyando. Voy a hacer un resumen de lo que es el portafolio y, por favor, cualquier duda, con toda confianza, búsquenme a mí y contestamos las dudas que puedan tener. ¿De acuerdo? Entonces, empezamos.
Thank you, Herman. Go ahead.
Hello, everyone. I hope you can. So, we're happy to be here in Mexico. Dave and I are based out of the US, and we are responsible for the machine tool software portfolio. And we started about back in the US with this relatively new portfolio and made some experiences about Industry 4.0. And we'd like to share these experiences with you and talk a little bit about our product as well. With that, so as you may know, that Siemens is a pretty big organization. We are into pretty much everything from energy, infrastructure, healthcare. So and we come from Siemens Digital Industries. And as the name Digital Industries says, it's all about digitalization and transforming manufacturing, or helping manufacturers transform the factories or digitalize them based on the new technologies and concepts. So with that, I'd like to hand over to Dave to talk a little bit about some of the aspects here.
Thanks, Vivek. And speaking of the digital industry side of things, in the beginning, starting with the digital twin aspect of things. So everybody's heard this term, I'm sure, quite frequently, but it's kind of the basis of validation before you go to production. It really, at the end of the day, can save a lot of money, a lot of time, a lot of headache. So one of the pillars being the digital twin side of things. And then, should I keep going to the digital thread?
Yeah.
And then we move over into the digital thread, collecting, analyzing, evaluating data, looking at a lot of data, trying to make some educated decisions upon that data to ultimately make our product, our process better at the end of the day. And then kind of wrapping up with the digitalization services. Maybe you would like to speak on the services?
Yeah, so with this offering, we're able to have a complete... So with this, we have a complete offering as far as digitalization is concerned across different verticals, across different technologies, and also being able to actually implement this at your factories or support you in the integration. So here I'd like to explain how we got here. So as you can see, we started investing a lot of money into software companies. It started in 2007, and I think the most famous one, what everyone knows, is UGS. And with that, we have acquired various different companies. The latest ones have been Pixium, Mendix is maybe known. So with this, we have a really comprehensive portfolio and technologies to address these challenges of digitalization. I don't know why. For some reason, it's getting blank.
I'm not exactly sure.
En En el Inter les quiero explicar, el tema de los gemelos digitales es un concepto que tiene cerca de 30 años, pero conforme se ha desarrollado la tecnología se van consolidando los gemelos digitales. Lo que explica la gráfica es la evolución y la consolidación del portafolio que ha hecho Siemens a través de los años para poder ir complementando los gemelos digitales en diferentes áreas. El gemelo digital del que les queremos platicar el día de hoy es el gemelo digital de los CNCs, ¿sí? Porque conocemos el gemelo digital del producto, ¿no? Que puede ser el producto virtual, conocemos el gemelo digital del proceso. Bueno, nosotros queremos ahondar en lo que es el gemelo digital del CNC y del proceso de maquinado, ¿sí? Y es un poco el tema. Y esta es la evolución de las compañías que se han integrado para poder complementar esa visión de gemelos digitales. Okay, go ahead.
So to go a little bit deeper, how we do this, we work not only in products but platforms. So basically we come from an automation platform, and as you can see down below, we have field devices, controllers. Fairly new topic is edge computing. So we have, when I say platform, it's not only about Siemens products being able to work here, we also integrate, for example, applications from partners, or machine builders, equipment builders, end users who can differentiate themselves or customize their application. So we also have MES systems. We have a cloud-based ecosystem called MindSphere, as well as Mendix, which I mentioned previously, of the latest acquisition, to be able to relatively simply do the application by yourself, because Mendix, as you might know, is a low-code application, so you don't need say complex programming know-how. You can pretty much easily do it by yourself if you need.
Vale la pena hacer un complemento. Los gemelos digitales en el piso de planta están convergiendo dos tecnologías. La tecnología OT, ¿no? Operation Technologies, que es todo lo que utilizamos para colectar información del piso de planta, y la tecnología de IT, ¿no? Al combinar las dos cosas, lo que estamos logrando es que la información que se está recolectando en tiempo real en el piso de planta se pueda explotar de una manera más eficiente en los sistemas de negocio. Entonces, estas son las diferentes capas. Digamos, el primer reto cuando queremos tomar el control en la digitalización de los CNCs es poder tener una estrategia adecuada de colección de datos, de extracción de datos, y eso lo hacemos a través del controlador, ¿no? Con el controlador extraemos todos los datos y después esos datos los analizamos para montar algún tablero de control que podemos ir desarrollando por capas. Esa, digamos, sería la primera fase.
Come on. So basically, digitalization, the story, there's a lot of headlines in the industry today, a lot of information that can be gleaned from collecting data, getting information, but what we see from our customers specifically are asking us to provide these tools, these softwares, these mechanisms, and our know-how and experience from other projects that we've delivered to get further information. Just some of the headlines from, you know, Ford, for example, or aerospace and defense, agricultural. Everyone recognizes, at least from the manufacturing aspect, the need, the desire for the information and the connectivity and the streamlining of information, essentially. We'll go to the next. So a little bit of what we're bringing to the table is, again, sharing our experiences with you, the audience here today. Some of the typical decision-making processes that we see, it's clearly discover. You identify an opportunity, an area for improvement. You define that opportunity, the project team, the people responsible, the KPIs as well. So, you know, when you begin, you validate and you end. Of course, next being validation, right? You validate what you've tested. Did we meet the KPIs? Did I communicate to the team? Did I bring everybody on board? Is everybody connected? And then deliver and scalability. If we've done the top three, then we should be able to easily replicate, move on, and work on the next digital projects. Next slide.
So we have a couple of years of experience now, and people ask us typically, what are your greatest challenges? And this kind of repeats itself, and here's some hints as to, how you can avoid these challenges and mitigate them. So let me start with, the budget topic, right? So it's a often discussed budget, like how much do I have to invest in this? And the answer to this is not simple because, the budget could be big, the budget could be small, but look at what you can afford and try to find a low-hanging fruit, try to find something small, right? That's the key behind this. So, but anyway, budget is something you need to kind of clarify up front. The second thing is, which is again tied to the budget, is which project are you going to focus in? So I wouldn't really advise to take a massive, large-scale project on if you don't have any experience. So project identification is a key issue that needs to be thought out well before you go for it. And the other thing is also communication. So sometimes we've seen projects that some people know about in the company, some people don't know about it. Then when they are confronted with it, it leads to some escalation. So that's another challenge. Validation, Dave mentioned validation. So at every point, whether it's at the beginning of the project, when you have done a proof of concept, it's very important to see, okay, where do you stand? I mean, and oftentimes you fail. It's okay to fail, but you need to say, how can you learn from this? And you have to do this at every stage of your digital transformation journey. Sustainability is also important because often we see that there's a budget available. There are some people who are made responsible, but then, after a year or so, we see that the project has just died because no one was really there to take care of this project and ensure there's a continuity in this product. And lastly is the decision itself. Maybe it's not lastly. It's as you can see, it's a circle. So you need to have, if you don't have a clear decision from management, and sometimes that is missing, you have to have the, I would say, stakeholder buy-in, and if that's missing, that's also a big challenge here. So with that, we could work on, okay, how are these challenges addressed? So Dave, what would you say is the biggest challenges or the biggest solutions, and how did you address these challenges with these solutions?
Hello. So referencing our slide that we have here, when we worked successfully with some of our end customers on these journeys, we just bulleted some common points, if you will, that we've identified that's a factor for overcoming some of these challenges. Number one is leadership buy-in. You should have some top-level sponsorship supporting the digital transformation that the customer is going to go through. Building capabilities of the workforce of the future is extremely key. As we bring new people onto a company, we want them to be easily educated and integrated into these very complex decision-making processes and programs going down the road. Can I keep going? Okay. Of course, we talked about communication, always constantly bringing everybody onto the same page. I don't think you can over-communicate enough. That's very key. Vivek mentioned budget. It's definitely advantageous to have a budget defined, but you need to understand that it's probably going to grow. It's going to be more than what you've defined as a budget. So you need to be prepared to put a little more into the budget to see the projects to the end. Empowering people to work new ways. Validate and replicate, like I mentioned before. And again, communicating, understanding the information, learning how to apply the information. That's extremely key. So you can take advantage of what that information is providing to you. We'll go to the next.
Complementando un poco el mensaje que queremos darles aquí, la digitalización es un camino, no es algo binario. Es muy importante tener la visión, tener el apoyo ejecutivo para poder desarrollar este tipo de proyectos. Entonces, hay que prepararse, hay que tener la visión, hay que comunicarla y hay que tener el apoyo para lograr que sea un éxito. Y uno de los beneficios es que logramos atacar muy fuertemente los costos operativos. Entonces, los proyectos de digitalización de CNC, el retorno a la inversión es muy rápido, muy fácil de justificar y de documentar.
So the other question we get asked is ROI, right? So if I invest in this, what is the return of invest, or what's the money? What can I save? So for that, we have to actually look into what are your costs, right? What are the costs of a machine tool? What is the cost of running a machine tool? So you have maybe invested in an expensive machine. Now you have that machine 24 hours in your facility. How can you best utilize that machine, right? So what we have found out, we have made a kind of an analysis that you typically have like 14 hours for a planned production time. Maybe we're talking about 2 shifts, and that you can break down again, as you can see. Sorry about that. So you can break it down into productive machining time, but also, as you all know, there are tool changes, setup, breakdowns, and other issues that influence the productivity of the machine. And even if you look at the machining time itself, things like tool, spindle transportation, again takes up time. And finally, you're only left with, in this analysis, 6 hours of true, productive time where the spindle is machining. So with that, actually, based on the calculations we have done, you're losing actually costs of $1,500 a day based off $80 machine hour rate. So you have typically a machine hour rate fixed for your calculation of maybe estimating your cost and your parts. So this is a lot of money you can save, and this is what you have to look into when you invest into Industry 4.0 solutions. What's the money I can save from a total production time of a machine? And one of the bigger factors that influences the tool cost, and Dave, who's has a lot of experience in tool, and obviously talk a lot to this.
Certainly, yeah. Thanks, Vivek. So what we see from let's say a tool management perspective, about 20 to 25% of the overall production, there are delays caused by tooling related issues. So some of those issues are tool preparation and the time that the tool is used. So in your tool room, maybe looking for the holder to go into that end mill, or vice versa, or that collet, wherever it may be. There's a lot of time and money spent doing those activities. 10% of it, clearly overall machining setup time. So changing jobs over, what tools do I pull? What tools do I put in? It would be great to know what tools did I need to take out, what could I reuse, right? But it's not usually practiced that way. Also, about 15% of the tools, those costs are external magazines, if you will, stored at the machine, on a cart, on a rack, next to the machine to be used for another job later. So there's a tremendous amount of savings to be garnered by utilizing some very rudimentary tool management processes. And these are some of the projects that we've worked on, actually. So.
Thanks, Dave. And a further analysis that we did as to, okay, these are the costs, and how much cost can you reduce, right? So we have now separated this into, machine. As you can see, the example is, for this is we have 3 NC programmers who make programs for 10 machines, 2 shifts, and the machine costs are approximately, let's say, $80 or 80 euros per hour. So this is what we find. We find that the biggest costs are in the machine cost itself, that at the machine, right? But then we have also costs that are occurring at the programming side, in the tool room, and also for the tool costs that Dave just mentioned. So in every area, there's potential to save costs, right? And can you measure these cost savings accurately in every project? No, you can't. That's why it's very important to get started, because as you get started, you'll see the benefit of these cost reductions. And here's one example for the machine cost itself, which we have in our portfolio, and that is something called adaptive control. So addressing the cost at the machine. So what you can do, there's a software, and the software works very simply by looking at the load, of the machine, and it adjusts the speed, the feed rate. So when you are, for example, when you program a part, it's an ideal feed rate that you program, right? So you don't know what's happening really at the machine. What is the material hardness? What is the tool sharpness, or anything that may occur? But this acts like a real-time sensor, so it can, in real time, change the feed rate. For example, if you're air cutting, and it'll speed up the feed rate. It'll go fast, and as you can see here, depending on the depth of the cut, obviously you can. If it's a low depth, you can go faster. If it's a deeper cut, then you have to go slower. But it automatically adjusts, and with this way, you really save cycle time. And we have seen cycle time saving from anywhere from 10 to 25%. And especially in the automotive industry, which this area is famous for, I think every minute or even a couple of seconds you save, that brings a lot of your costs down. And here is a calculation of how you can calculate. So this is one of the areas where you can have a clear ROI calculation, and Dave will go a little bit in detail here.
Yeah, I don't want to go into too much detail and make it a product pitch,
Okay.
but in terms of ROI, we take some general information that we work with the customer to collect, those KPIs that I mentioned in the beginning. So we've defined a kind of a target, and we have the validated information pre-test and then post-test. So after we implement, we fine-tune, and we validate it. Basically in the bottom right-hand corner, the product pays for itself in about 4 months usually, and they're seeing about $60,000 a year on that machine in savings. Just as an example project we worked on with another customer around digitalization.
Aquí hago otra vez una pausa para checar que van siguiendo la temática. Esto que están viendo en pantalla es cómo podemos ayudar a reducir el costo de una manera muy eficiente en la operación de los centros de maquinado. Y una de esas áreas de mejora que es muy rápido de lograr es reducir los tiempos ciclo de maquinado, reducir los desgastes de la herramienta y prolongar la vida de los usillos. Entonces se hace a través de un software que está monitoreando precisamente la operación de maquinado, y conforme va detectando diferentes esfuerzos en el proceso, va aumentando la velocidad si no hay esfuerzos fuertes, o la va disminuyendo si estamos cortando a mayor profundidad, etc. Para no repetir todo el mensaje, al final nosotros trabajamos con ustedes en construir un retorno en la inversión de su escenario, porque no todos los procesos de maquinado se justifican igual. Hay procesos que son muy rentables, muy rápidos. Hay unos en los que se puede reducir o el retorno viene en la reducción del tiempo ciclo. En otros el retorno viene en el ahorro, en la extensión de la vida de las herramientas o la reducción de los costos de mantenimiento del usillo.
Thank you, Herman. So we're coming a little bit of how does Siemens support in this digitalization journey with our offerings, especially focusing very much on machine tools. So we have basically, very simply to understand, 3 main categories. That is smart shop floor. So this looks at the whole optimization of the shop floor. For example, you're familiar with machine monitoring, OEE, resource management, tool management. Then we have something called smart virtual machine. And smart virtual machine is, for example, the topic of digital twin, what Dave mentioned in the beginning. So this is basically optimizing the process before you actually produce on the machine. We'll talk a little bit more in detail about that. And then we have the smart machine itself and the adaptive control software I just showed. That is, for example, part of the smart machine to improve the performance of the machine. And there are other aspects to it as well. We have edge processing, which we also consider under the category of smart machine. So with that, I'll ask Dave to go a little bit more into detail.
Yeah, thanks, Vivek. So looking from the Siemens perspective of the smart shop floor, this is just a very quick overview of the applications that we use to support our customers in their digital transformation here. So starting at the shop floor to the virtual machine to the smart machine. We're touching people, machines, servers, data points, all kinds of information, trying to bring everything together to optimize the machine, the manufacturing process with the know-how that we have, the tools that we have available, the hardware, and the workforce that we have available also.
And what I would like to mention here before I give to Herman, this is not only for Siemens controllers. So what we also try to do is address our solutions to the whole factory, which are also maybe not only Siemens. Yeah, so we are also working on what we call as third party, and that your machine shop can be utilized for any kind of solution which we offer. With this, I'd like to give to Herman also to give you the summary in Spanish.
Exacto, thank you, Vivek. Esta gráfica resume un poco la visión y la estrategia que tenemos en Siemens. Básicamente es, a través de la digitalización, dotar de inteligencia a lo que es el piso de producción y específicamente a las máquinas. Y lo hacemos en 3 niveles principales, ¿no? Dotar de toda la inteligencia que yo puedo aplicar directamente en la mejora del proceso en la máquina. Entonces, normalmente son aplicaciones que instalamos en el controlador y estas aplicaciones me permiten tener maquinado más rápido, poder estar monitoreando y mejorando la calidad que yo estoy generando en mis maquinados, ¿no? Tener mayor tiempo de producción en la máquina, porque vieron que realmente el tiempo productivo de la máquina llega a ser inclusive una cuarta parte del tiempo útil completo. El siguiente nivel es cuando hablo de la máquina virtual inteligente. Y este nivel me ayuda muchísimo en la parte de planeación del proceso. Aquí yo tengo un gemelo digital de la máquina, de tal manera que los maquinados los puedo anticipar y planear en una computadora, probarlos, estar seguro que no va a haber colisiones, que no voy a tener problemas finales con el código. Aquí también puedo probar muy bien el código. Y entonces con esa confianza me voy directamente a la máquina e implemento el cambio o el proceso que quiero trabajar. Y el tercer nivel es cuando hablamos del piso inteligente. En el piso inteligente, entonces ya tomo el conjunto de máquinas que puedan estar dentro de una línea, exportando los diferentes KPIs que obtengo del controlador para cálculos de OE, para cálculos de calidad, y esa información me puede servir para la planeación de la producción. Aquí es donde yo empiezo a exportar información, a integrar información con los sistemas de producción, los ERPs o los sistemas de calidad. Y quería hacerles yo una pregunta. ¿Todos conocen los sistemas CAM? ¿Todos han trabajado con algún sistema CAM? ¿Sí? ¿Cuántos de ustedes han programado máquinas? ¿Conocen programación de máquina? ¿Sí? Bueno, lo que quiero decirles es que después del mundo del CAM hay un mundo impresionante de optimización para el proceso de maquinado, ¿no? Yo inicié conociendo el tema CAM y pensaba, el CAM optimizo mi trayectoria, optimizo en base a mi geometría, pero resulta que una vez que tienes el código G, que es el código que vas a ejecutar en la máquina, ahí puedes hacer todavía un montón de optimizaciones que se van a traducir en mejora en la calidad del producto, menos mermas, etcétera. Entonces, este enfoque les ayuda muchísimo a lograr eso. Y se hacen esas 4 etapas que se ven a la derecha, ¿no? Preparación, ¿no? Monitoreo, transparencia de la máquina, etcétera.
Thank you. Okay, now we come to the topic of the so-called digital twin. So what is digital twin? You might have heard of this several times. I mean, this is showing like a like an infinity loop because it's a constant process. Yeah, you have the virtual part and you have the real part. And like I said, today we have the technology to model everything we can in a virtual world, which includes the whole machine, the way the machine is working, the mechanics, and even the part itself, to an extent that by the time you're building the machine or you're producing the machine on the part, you have a fairly optimized process already. Now we have actually Track here, who we work, and they also sell the machine with a digital twin. So that's where the real use comes. Say from a selling process, they already know what machine they're getting because it's a digital twin which they can test out virtually, but also they can try out their part, right? So they know what's the cycle time and so on. So with that, here's an example of how the things would work. So we have here, for example, the our NX systems, NX CAD, NX CAM. I don't know if you're familiar, but for that matter, it could be any CAM system. So here we are able, for example, using the post and posting it on the digital twin, right? And in the digital twin, you can see how the program is, how the cycle time is. And then we have an analysis tool called Analyze My Workpiece Toolpath. And with this, you can see, as you can see, there's some red and blue colors. These are basically velocity profiles, right? So you know where the velocity is going down. We can also zoom in, see the toolpaths. And we can actually do one thing. We can compare the output of this with the CAM toolpath. And we can compare where the problems are. So this is the virtual world. So we are only optimizing in the virtual world. And then we are moving this over to the real world and manufacturing the part. And then we can again compare the output of the trace output back into the program to further optimize the part, right? So, and to complete this whole solution, we also have machine monitoring. So we have MindSphere, we have on-prem monitoring where you can feed back the loop again to the systems, to the production systems. So you can see this is a whole complete solutions to constantly optimize your production.
Para complementar un poco lo que mencionó Vivek y les dije hace un momento, del lado izquierdo tienen el gemelo digital de lo que es su entorno de producción, ¿no? Empezando por el sistema CAM, por eso les preguntaba si conocían algún sistema CAM, pero donde termina el CAM, aquí empezamos nosotros en la optimización del proceso.
Thank you so much. How are we doing?
Tenemos el controlador y después tenemos algunas aplicaciones ya muy específicas que me hacen un análisis sobre el maquinado. Y eso lo exportamos al centro de maquinado real y en complemento colectamos información para meterlo en los sistemas empresariales. Entonces ahí estamos haciendo esa dualidad entre el modelo virtual y el modelo real.
Gracias. So one more interest, so these are just some examples. We have a lot more, just some examples where we think we can really, be of support to you. So here's another example with an edge box. So we have recently introduced something called the Cinematic Edge. So the most important about this industrial edge box is that it can capture high frequency machining information. So how is this used? This is used in getting, like information like tool path or loads or coordinate information and optimize this. So essentially you can see here between the edge box and the monitoring system, you can constantly optimize it. And I'll jump really quickly because we don't have too much time. Sorry. So here you can see so it's like a machine learning. So you can say, okay, what tolerance level is accepted for a part? Say in automotive, you're manufacturing many parts, right? So you have certain tolerance level. So you can define the tolerance level in a data model, and you can define this in the edge box. So if because of some machine dynamics or maybe some programming issues, it's going off, the machine will send a notification to the operator, or you can define any task to either say, okay, this is a bad part or a good part, or stop the machine, whatever, right? So this is like an online quality monitoring system. Yeah. So this is another example. There are many more applications on the industrial edge. So there's just a few. This is based on camera-based systems to see if the workpiece is placed correctly, and many, many other applications. Unfortunately, we're running out of time because I want to give you some time for questions and answers. But Herman, I think if you can do a real quick summary, and then we can move over to the Q&A.
Sí, para concluir o empezar con las conclusiones y poder pasar a la parte de preguntas y respuestas. Se me fue la idea. Lo que quería yo concluirles es que hay diferentes factores que podemos analizar extrayendo los datos para hacer el análisis del proceso. The next one, please. The next one. Just one previous. Y digamos el extremo de la digitalización o el nivel de madurez mayor que se puede tener en la digitalización puede ser para la gestión de la información que va al centro maquinado. Por ejemplo, utilizar tecnología de inteligencia artificial colocando una cámara que me puede ayudar a validar que el setup, que no tenemos unos soportes o fixtures que no son correctos para el maquinado que se va a hacer y prevenir colisiones, ¿no? Esa es una de las aplicaciones. Entonces podemos tener una cámara que está filmando el entorno productivo y si ve que el layout no es el correcto para el proceso que se va a correr, lo detiene. Ese es un ejemplo. El otro caso típico es que tenemos varias líneas de producción que corremos varios productos con diferentes programas. Lo típico es que esos programas eventualmente se puedan modificar directamente en la máquina, se salvan, se va a correr otra pieza y no se hizo el cambio de programa. Eso genera colisiones, etcétera. Entonces, esto también se puede gestionar a través de tener un control como si fuera un disco duro donde yo publico los programas para que los operarios puedan o no utilizarlos de acuerdo a la pieza que van a fabricar. Entonces, en términos generales, estos son algunos ejemplos que queríamos compartirles de cómo a través de la digitalización de los centros de maquinado podemos ayudarlos a aumentar la productividad, reducir los costos de operación, costos de mantenimiento y pues definitivamente nuestra intención es poder trabajar en algún proyecto en conjunto. Les apoyamos desde la parte de estudios de retorno de inversión y pues iniciamos la sesión de preguntas, respuestas, dudas que tengan. Si alguna pregunta en particular quieren dirigirla a Dave o a Vivek, yo puedo hacer una traducción, o si hablan inglés, adelante. ¿Alguien tiene alguna pregunta o comentario con respecto a la sesión? ¿Algo adicional que quieran saber?
Thank you, Herman. So we have come to the end of the presentation. We just asked Dave to do a quick summary of what we talked about.
Yeah. Thanks, Vivek. So really quickly, just some key takeaways. What's really important for me personally is for you to know that I'm not from the controller side of the business. We're from the machine tool software side of the business. Vivek mentioned earlier, it's kind of a newer initiative where we work on these digitalization, these projects together with the teams and things, but I hope that the information that we could share with you guys, you found some benefit. Just some key takeaways: be bold, take the chance. The technology is already here. Don't be afraid, it's available. Get started right away. And really, most importantly, is it's a marathon, not a sprint. It takes several sprints to complete this. This transformation is a journey. And finding the right people to walk down that path with you is very, very important. And you need to make sure your suppliers work together to accommodate your needs at the end of the day. So, Vivek, anything from your side?
No, I think, yeah. So, yeah, just get started. Don't think too much, honestly. And otherwise, you really, have the danger of getting left behind because people are really getting started on this journey and, really encourage you to do that. With that, I'll like to hand over to Herman to summarize and go over to Q&A. Yeah?
Sí, bueno, para concluir rápidamente, yo les diría que la ventaja del mundo digital es que lo que rompan o golpeen ahí no pasa nada, no nos cuesta dinero, ¿no? Lo que sucede en el piso de planta es otra cosa. Pero entonces finalmente entremos a la zona de preguntas. ¿Hay alguien que tenga alguna pregunta, alguna duda, algo que quieran que ampliemos como concepto?
Hola, buenas tardes. Respecto a otro tipo de sistemas parecidos al que ahorita maneja Siemens, ¿cuáles serían las ventajas? Yo pongo como ejemplo Radan, que es una plataforma similar, que toma un punto o un código G, lo transforma a un gemelo, pero ¿qué ventajas tendría este software de Siemens o esta aplicación de Siemens versus otras que ya existen en el mercado?
Sí, desconozco a detalle el que mencionas, pero nuestros beneficios principales es la integración directa e intensa que tenemos con el controlador de la máquina. Digamos, el controlador finalmente es una computadora que está sensando un montón de componentes del CNC. Con nuestro software extraemos toda esa información de una manera muy eficiente y directa. Entonces podemos controlar muchos parámetros que no cualquier solución de monitoreo te puede controlar. Ese sería el principal beneficio. Extraer la información muy a detalle y después exponer esa información a diferentes sistemas analíticos, por ejemplo, para el tema de la calidad, donde puedo hacer una validación de la calidad basada en cómo se está generando el movimiento del cabezal muy a detalle. O sea, una de las gráficas que presentó de colores me dice cuáles son las velocidades que se están llevando en cada punto del maquinado, ¿no? Del código. Y entonces, de una manera muy precisa, tú puedes editar ese pedazo de código para aumentar o disminuir la velocidad y entonces tener una herramienta muy versátil para mejorar tu calidad de maquinado. Son ese tipo de aplicaciones que no todos los proveedores ofrecen. Y yo te diría que en el caso de Siemens, controlador de Siemens en particular, la integración es completamente transparente. Vive que mencionó que tenemos integración con otros controladores también. Lo que hacemos ahí es colocamos una pequeña interfase y el software es el mismo. Entonces extraemos información y tenemos varias áreas en donde podemos ayudar a analizar y mejorar los procesos de manufactura. ¿Alguna otra duda, pregunta, inquietud? En general, ¿les hizo sentido la problemática que planteamos y que resolvemos? ¿Sí les sucede con frecuencia este tipo de cosas? ¿Sí? A ver, ¿alguno de ustedes ha trabajado con gemelos digitales en algún área? ¿No? Entonces, ¿todo lo has...? ¿Sí? ¿Nos puedes compartir un poco tu experiencia con gemelos digitales?
Sí, en la parte de punzonado de lámina, el gemelo digital hacías el punzonado de la lámina fuera de línea y se guardaba en la nube y de la nube lo llamaba el operador de la máquina, ¿no? Pero tú simulabas el golpe de la punzonadora de tal manera que podías tener un estimado de tiempos y también podías revisar si no había colisión con algunos de los clamps, así como en términos generales.
Ese es un buen ejemplo. Nosotros, el gemelo digital, podemos tener el CNC completo con toda la cinemática, los movimientos, cómo se alimentan las herramientas. Tenemos una validación del código G en tiempo real para ver qué pedazo de código se está ejecutando y en el gemelo digital ver cómo se está moviendo. Y eso que ustedes ven ahí es exactamente lo mismo que va a suceder en la máquina. Entonces, el nivel de integración y el nivel de incertidumbre o riesgo que va a existir después de que ustedes hagan esta prueba sobre el gemelo digital es prácticamente cero. Entonces, son esos algunos de los beneficios. Y en esta industria, golpear un equipo, dañar un equipo, primero es caro porque hay que reponerlo, ¿no? Cuesta. Segundo, hay que esperar a que lleguen las refracciones. Tercero, podemos detener una línea de producción. Entonces, eso yéndonos al lado negativo. Si me voy al lado positivo y yo mejoro y optimizo mi proceso a través de centros de maquinado, puedo aumentar la capacidad de mi planta sin hacer una inversión inicial. Entonces, en realidad son áreas de oportunidad muy interesantes. Ahorita que los niveles de producción son muy inciertos, ¿no? De pronto tenemos que poner la máxima capacidad que ponemos, de pronto nos faltan piezas, etcétera. Este tipo de soluciones ayudan muchísimo a tener flexibilidad en entornos inciertos como los que desafortunadamente tenemos ahorita y no se ve que vaya a acabar muy pronto. ¿Alguna pregunta, comentario adicional? ¿No? Bueno, si no, les agradecemos muchísimo a Dave y a Vivek el tiempo, y por supuesto a ustedes que nos hayan dedicado una hora de su tiempo, y estamos a sus órdenes para cualquier cosa que podamos trabajar juntos. Gracias.
Muchas gracias.